In the previous video, we showed that the derivative of sine of x was equal to cosine of x. And what I want to do now is I want to do the proof for the derivative of cosine of x. And a lot of it's going to follow the same way that that proof did for the derivative of sine of x. So if I want to take the derivative of the cosine of x, and I'm going to use my limit definition to prove what this equals. This is the limit as h approaches 0. Well, I need to input x plus h, so this is going to be the cosine of x plus h minus the cosine of x all over h. Just like what I did with my proof of sine of x, I need to use an angle addition identity here for the cosine of x plus h. And it just so happens that if I have the cosine of x plus h, that is equal to the cosine, let me make sure I put my limit statement here, the limit as h approaches 0 of the cosine of x times the cosine of h minus the sine of x times the sine of h. That's the angle addition identity for cosine, that if I take cosine of x plus h, it's cosine of x, cosine of h, minus sine of x, sine of h, and then I need to not forget this minus cosine of x right here, and it's all over h. Well, just like I did in the previous proof, I've got this thing happening here where I can see sine of h over h happening, and we know what the limit as h approaches 0 of that is equal to. So I'm going to do another algebraic rewrite here where I really want this sine of h over h. So let's say that I have negative sine of x, because there is a minus sign in front of it. So negative sine of x, sine of h, all over h. So there's this kind of inner piece right here. And then let's add it to, make sure that we have everything else here, limit as h approaches 0 of cosine of x times the cosine of h minus the cosine of x all over h. And so you can kind of see that I'm going to get the same kind of idea here. So I really want to have the limit as h approaches 0 of sine of h over h. So this is the limit as h approaches 0 of sine of h over h times the limit as h approaches 0 of that negative sine of x. So there's this piece right here split up, and this is nice because I know what the limit of h approaches 0 of sine of h over h is. Now then, we need to do the same kind of algebraic maneuvering over here that we did in the previous video. So what I want to factor out is I can see that there's a cosine of x in the numerator, and again, I want it to be 1 minus cosine of h when I'm left. So I'm actually going to factor out a negative cosine of x right here. And when I do that, what I'm left with then is the limit as h approaches 0. The negative cosine of x factored out of there is going to be 1. Negative cosine of x factored out of here is going to be minus the cosine of h. And this is all over h. And now I can use some known values here. The limit as h approaches sine of h over h, that's equal to 1. Limit as h approaches 0 of negative sine of x. Again, I don't have any kind of h to really address here, so that's just going to be negative sine of x. I'll use some grouping there not to create any confusion with the negative sign. Limit of h approaches 0 of negative cosine of x is going to be negative cosine of x. And this limit right here, the limit as h approaches 0 of 1 minus cosine of h over h, is equal to 0. So again, this piece is going to zero out, and what I'm left with is negative sine of x. And so I get another interesting result here. There's a good relationship between sine and cosine and their derivatives. We said in the previous video that the derivative of sine of x is cosine of x, and now we've shown that the derivative of cosine of x, make sure you don't lose sight of this negative, but the derivative of cosine of x is equal to the negative sine of x. And so it's kind of nice and easy to take the derivatives of sine and cosine because they're opposites of each other. Just make sure when you take the derivative of cosine of x that you get negative sine of x in return.